In this following reaction, we need to find the A's. So usually in every questions we need to identify the product, but this question they are given the product. We need to identify the what type of reactant it is. The first case they are doing with the uh, bromination by doing with the photolysis and alcoholic KOH. So obviously it undergo the beta hydrogen elimination, and this is for this two. Okay, third and fourth one, it's a combo of the ozonolysis. This is for the ozonolysis process. And last one, aldol condensation reaction. Okay, so first of all we need to find we need to write the all the options. Option A, I have the cyclohexane, and option B, I have the I have 1 methyl cyclobentane. Option C, I have 1 comma 2 dimethyl cyclobutane. And option D, 1 ethyl cyclobentane I have. So first you do with the photolysis. If you do with the photolysis means here the carbon free radical will be formed. So here what type of carbon free radical will be formed? Here it's a secondary carbon free radical, anywhere it will be formed, and here it will form the tertiary carbon free radical, and this is the position where form the tertiary carbon free radical. Here also what? Tertiary carbon free radical. So if you do with the after homolytic bond breaking, you added with the bromine, definitely the bromine war is going to be attached with this area, in this area. So Br and Br. So after you're doing with the beta hydrogen elimination. So beta hydrogen elimination, it says that it following the Zaitsev rule. A Zaitsev rule, it's talking about the around carbon-carbon double bond, around the carbon-carbon double bond. So which R groups are, okay, which carbon-carbon double bond consists of more number of R group, that is known as the major product. So in this particular two double bond system, here I have the 2R system, here also there are 3R system. So this would be the major product, this would be the minor product. So in this case we need to identify the predict the double bond over to here. This is the alpha carbon, this is a beta and beta 1, and this is the alpha, beta, beta, and this is also beta. Alpha, beta, and this is beta, and this is also beta. This is alpha, beta carbon, and beta carbon. And now we need to identify the structure. I mean, after doing with the alcoholic KOH, you got the alkene system like this. For B, option B system, if you do with the uh, beta hydrogen elimination, you will get the product like this. Option C, you are going to get the product like this. Option D, you get the product like this. So now, so this is the major product of the alkene system. And option C, they are doing with the ozonolysis. So ozonolysis, how will you do? In the ozonolysis system, between the carbon carbon double bond, we need to add the two number of oxygen. So here I break the double bond and add the two number of oxygen. Here also I need to break the double bond. Okay, between the carbon carbon double bond, I need to add the two number of oxygen. So here what type of product I can get? Aldehyde functional group I will going to get CH2, 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 and CH2 and aldehyde functional group. And here it will form the ketone functional group, and moreover aldehyde functional group also is present. And now C double bond O and C double bond O. And here what will happen? C double bond O and C double bond O, aldehyde will be get. And what is the next reagent? The next reagent I need to add the aqueous KOH, as well as I am doing with the heating process, which is nothing but aldol condensation reaction. So here this is the alpha nucleophile of the system is going to be attacked, therefore the ring form will be formed. So what is the ring form? 1, 2, 3, 4, 5. So here I got the 5-member ring. So in this alpha system is going to be attacked in this particular nucleophile. So this concept is nothing but intramolecular aldol condensation reaction. So it will form the 1 2 3 4 there. Here it will form the 4-member ring, and in this case here it will form the alpha carbon is going to be attacked. How many ring will be formed? 1 2 3 4 5. So 5-member ring is going to be get that. And here in this case this is the alpha position nucleophile will be formed. Here intramolecularly nucleophilic addition reaction is take over. 1 2 3 4. So here 4-member ring is going to be formed there. So in that reactant, how many, what is the ring system? 1 2 3 4 5. There will be a 5-member ring. So 4-member ring, 5-member ring, obviously it's not came. So obviously what is that? We can easy to remove the option B also, and option D also it's won't came. And remaining, what is the possibility of that? The possibility of that option A and option C is a possible of the correct answers. And now in this reactant I have the, sorry, in this product I have the aldehyde functional group. So 5-member of the system, here I have the ketone functional group, here I have the ketone functional group, but here I have the aldehyde functional group. So obviously option A is the correct one. Okay, so first what they are doing with, they are taking with the cyclohexane. After you take the cyclohexane, you do with the bromination in presence of photolysis. So you got the 1-bromo cyclohexane you will be get. So after beta hydrogen elimination, they are adding with the alcoholic KOH. So obviously the C double bond C will be formed. So once you do with the ozonolysis, what will happen? After formation of unstable intermediate of ozonide, it will be form the 2 number of carbonyl system. So we need to break the carbon-carbon double bond over to here, then we will add the 2 number of oxygen. So what type of the product I can going to get? There are 2 number of carbonyl system. I am going to be get that. So here aldehyde CH2, CH2, CH2 and CH2 and C double bond and CH2. So after that followed by they are doing with the aqueous NaOH. So aqueous NaOH, I have the 2 equivalent of the carbonyl system with the alpha hydrogen. So it obviously it undergo the intramolecular, it is a intramolecular aldol condensation, intramolecular aldol condensation reaction. Okay, so now here it will form the abstract the proton from the acidic proton. So now nucleophilic attack is take over. So now what will happen? I get the intermediate like this, 1 2 CO minus hydrogen and CH2 and aldehyde function will be present here a new sigma bond will be formed there. So straight over after doing with the protonation, what will happen? This O minus became the alcohol. So I got the product like this way. In this way I am going to be get that aldehyde. Here I got the aldehyde and OH and hydrogen. So after doing with the heating process, the elimination of water molecule will be possible. So removal of the beta hydrogen and alpha carbon, I have the hydrogen. So this two water molecule will be eliminated. So as a result, I going to get the alpha beta unsaturated carbonyl system. I am going to be get that. So here carbon carbon double bond and C double bond O and the hydrogen will be present. So obviously option A is the correct one. Thanks for watching.